Nice. So, hi everyone, my name is Lee. Today we'll talk about how to use NSO with Splunk. We also have a remote guest online from a development team. She's the developer for Observability Exporter. She will help out in the Q&A session. So you have a good opportunity to ask questions directly to our development team. So if you have any problem with setting up Observability Exporter, feel free to ask. But for my session here, I'm not gonna only focus on Observability Exporter. I will focus on a full package. We will use Observability Exporter to collect the time frame, time consumption, transaction-wise consumption. Then we're also going to use something called collectd to also stream to Splunk to collect the memory consumption. This was very useful. I used it multiple times when I solving the cases. Customer have auto memory problem and so on. This usually gives the perfect diagram to show when it starts spiking at what exact time and what's the, what's the pattern looks like. So when we have those things set it up, then you can start imagining what can we do about it. Is it only about showing this picture on Splunk, or what is so special about Splunk? So the good part of Splunk is you can also have this REST API. You can also construct your own performance testing and populate your performance testing data into Splunk. What I mean is, for example, order by user list or all kind of lists. You can do from 0 to 20,000 with, let's say, 10,000 apart, and have data stored in Splunk and see how exactly it performs between several different NSO versions here. And eventually, if you pre-populate data, then you can do much more. For example, you can do machine learning. You can do predict, let's say I only have data from 0 to 20,000. What happened with 30,000 and so on. Splunk has those functionality that can do the machine learning extended based on its app. So we will start with how we put the data into Splunk. As I mentioned, we're going to talk about the full package here. Then I also create this thing called performance data collector. It's not just a script with a loop. It's much more than that. I use a tool called logs. It's a testing framework based on Erlang. And the interaction here is just like a network engineer's mindset. You give a command to your script, for example, from NSO point as a commit, and I check if the return value that's come back is the same as what I expected or not. If it's not as what I'm expecting, I'm specifying the logs, it will say fail. If it's what I'm expecting, it will start collecting the time, memory, and so on. You will see. The diagram here is actually the vision we have, what we want the monitoring to look like. We want the NSO, we want the Splunk, we want the visualization, and we want if something went wrong, Splunk can signal NSO, and NSO can act on it without we touch anything. There's something we also call predictive service. I don't know if I'll have time to talk about it. We have mentioned this as a, let's say, a bonus point here. If we have time, we'll talk about. Otherwise, we have a booth outside. I will show you guys a demo on that one. So we start with, let's look at the collector, because if you want to use Observability Exporter, let's start with time. You need to set up collector because we use OpenTelemetry format here. We have a lot of customers have problem with set up the collector. It's hard. The most common question here is receiver and exporter. So NSO side, when you set up Observability Exporter, you actually set your connection towards the receiver. And this means that on your receiver side, you need to mention the IP address and the port that's going to be the same as you set up on your NSO, not on the exporter side. We keep seeing people set up the exporter side, which is toward the Splunk, and ask us why the 88 is not working on NSO, because you are talking to the collector on the receiver. Okay, we're not going to use gRPC today. We're going to use HTTP. And on the exporter side to Splunk, you have few things need to be set up. First, token, we're going to use HEC here. So which means HTTP. Your token, you get it from the token value in your HEC setup, while in the endpoint, you mention where's your Splunk, and it's always 8088. But the problem with Splunk is it by default, it enables SSL. So if you want to use HTTP here, in the global settings on Splunk, you need to disable SSL. If you just want to play around, but for security point of view, it's better to enable it. And then it's not only ends here. You also need to mention services collector. This is the full URL. You have to send it into service collector so HEC can process it. Otherwise, you will just say, oh, I have the IP address right. I have the port address right. Why isn't answering what I'm sending? Because it's come to a specific endpoint here. And then you need to mention the source as OTL, which is open telemetry format. Source type open telemetry format here. Also, index is, we're going to use in a while. It's basically telling the Splunk that what kind of data I'm sending. This will be very useful when you start filtering data in Splunk. Splunk use those filtering searching string. You don't want to plot the graph with all the data you have ever sent, right? So index is very useful. The rest is just my own habits. Even I don't use the HTTPS here, I also set skip verification as true, because unless I want to start using it, and I use self-signed certificate, I don't want to get myself in some kind of weird error comes out. I think I have a troubleshooting in the end that shows similar kind of log you will see on the collector side. Please. Yeah, sure.
Is Splunk on-prem, Splunk Enterprise?
When I'm doing testing, I'm using Enterprise, but it's the same because this is the exporter configuration on the collector. So if you use Enterprise, you need to use the remote. Where is the Splunk Cloud? I believe we're saying, right? Where is it located? As soon as the endpoint is correct, you will be able to send it. The problem now is Observability exporter, we don't support point-to-point yet. You have to have a collector to transfer, translate it.
Because the integration between NSO and Splunk was only possible with the OLI,
with the collector, yes.
Cloud version, not with the enterprise version.
And the enterprise version works. You just need to mention it as an internal IP address.
There was something in the past that OTel hack integration with Splunk Enterprise Core on-prem was not only with the Observability Cloud.
Yes, yes, but with a collector, because now you use open telemetry format. It's an open format, so it will work. So this is actually a very famous question, because now you're sending data not to Splunk directly. You're sending to the receiver of the collector now. He's going to translate for you to the open telemetry. It's the open format. Most of the dashboard application understand. That's why it works now. I understand what you mean. You want to use a one-to-one connection. You want to use a Splunk application add-on, right? So that won't work yet. We want people to use the collector, to use the open format. Much easier to maintain. Does that make sense?
Yeah.
I mean, we could write an app on Splunk side to make the parsing works, but the open standard is always more common-wise, right? We have a demo. I don't have time to show it, but we have QR code. You can try to run the demo, and you will Splunk an enterprise, and you will see it's working fine. Yeah, my test here is actually done based on enterprise, because, well, I didn't pay for the cloud license here. Yes. Also, that's what I thought. Also, you have internal data. You don't want it end up in the cloud. Then, if something happens, no, yeah, exactly what I thought. I will show the QR code in the end. Yeah, so you'll see. So two kind of data the observability exporter is actually sending. One of the most common question is, when we send in the metric, what exactly do I have it available? Previously, we didn't mention in the guide, but now we did. It's in your NSO installation, you actually have a YARN file called telf_ncs_metric.yarn. Everything inside this YARN file is actually what you are sending to the Splunk, or any kind of dashboard tool, actually. And for the event-wise, at this moment, we only limit on the progress trace, which is what you have on developer log. But what we are working on is, that's why we have developer on the line here. We are working on HA. See if we can have HA status sent to Splunk. And also observability exporter. Future, we also get requests to see if we can send something like audit log. So you don't have to use syslog, the rsyslog anymore. Those are the things we are trying to working on. It's something we are still doing proof of concept. If it works and we can find the use out of it, you probably will see in the future here. So on observability exporter side, now we're sending data through, right? But on the Splunk side, it's actually treating data in this structure. You have a data input. Data input is the HEC we'll talk about in the collector side. That you decide how the data came in. And for data input, it's hosting an index. That's the index part you're putting in the collector. You tell, when you're sending data, you specify what index is this data. Then later in the data input HEC, you tell the data input that if this index comes in, I will be the one taking care of it. So it's like you peeling an egg. It's one after another. Eventually, your data belongs to an index. Your index belongs to a data input. And then for each data you send, it comes with a trace ID. So if something goes wrong, you lost data or something, you should look for if the trace ID has been leaving on NSO, have been leaving on the collector, or have it arrived at Splunk or not. Or have it arrived at Splunk, or Splunk decide to ditch it in some way. So to configure this in the Splunk side, this is the data input we were saying in the outer shell here, and the index. So you create an index. Event is the trace. We're talking about progress trace. Metrics is the metric that the Young model is sending. Here we create the event, and then we put what we index we create for the event. We add it into the HTTP event collector as a full name. We said this collector, we only receive what this index, which events, comes to me. Eventually, you can specify multiple index for the same collector here. So if data comes in with this index in place, this HTTP event, which is the HEC collector, will taking care of it. So you don't have to have one index per collector, then you have a bunch of collector. That means you have a bunch of socket open, which is going to be a big problem, I guess, for some of the enterprise setup here. And by the way, this is the enterprise. You can see the UI. Cloud looks more fancier. And now you have the collector connected to the Splunk. On the NSO side, you need to make the configuration like this. So this is actually, I'm going to mention this once again, because there's too many problems has happened. This is the connection to the receiver on the collector, not the exporter, okay? So collector IP is where your collector located. Usually it's a Docker container and so on. And the port is the one you actually mentioned in your receiver setup on the collector, not the Splunk port here. And here I specify HTTP, but you can see you're also allowed to use gRPC. So if you use gRPC, you have to make sure that in the receiver configuration we just showed, it has the same port, basically. And sometimes, I know some customers have the need that you want the metric ends up in a different system than your progress trace. Then you can, in that case, specify these extra parameters. Metric host and metric port. Then you can have metric in one Splunk instance, and then your progress trace and other thing from Observability exporter, those traces, in another Splunk instance here. And another very popular question, you don't see progress configurable because you have to on-hat debug. It's actually hidden here. So now we have the time, or the time data. But time data usually don't mean much by itself. Let's see how we get the memory in the Splunk. So let's say if you have auto memory, you can see, is it because of something that's been running forever? If it's because something, the time consumption is getting long, and your memory is also consuming more, maybe it's a loop, right? So let's get the memory that the data was collected into Splunk. In here, you see, we don't have a collector anymore, because in the Splunk, it has an integration that already made. So this is the good part of Splunk. They have apps. And those apps is not just extending the ability of Splunk, it's also have parsers. You can extend the format Splunk can receive, which in this case, we extend the format that Splunk received from only OpenTelemetry exporter to collect the data. So this source type, Linux collect the HTTP JSON, is actually not exist in Splunk by default. But after you install the Splunk add-on for Linux, I'm not going to detail here. There's a QR code for the guide, very clear. Take a look. You then in this config.json file, you specify this source type will be taken care of by this add-on. Then in your index configuration, you will see, it's actually I already created, but you index a configuration, you can actually specify here, source type, Linux collect the HTTP JSON. So this index, not index, collector now will be able to receive data sending from collect D directly with memory data. And this is the one, how you configure this part from the HE side. Well, this is the guide, how you enable the type here. The reason I don't dig into much detail is those two are very good guys. It's basic step by step, 1 through 5. Just follow it, it will work. But the challenge here is how to make your operating system monitoring the NSO. So installing collect D is quite straightforward. You just apt get install, Debian way. Red Hat, I guess, is use different one. But when you install it, after you install it, you need to configure it. This is the good part. Here, I make it only monitoring the NSO core at the moment. But what happens if I have, let's say, my Java starts seeing a memory problem, my Java VM? Just change the process here to the same process name you see in top. I can change this to Java, then it will monitor in Java VM because NSO use Java as Java VM name, right? Here ncs.smp, that's the core name. And by only set up this, you monitoring is you tell the your collect D what process you are monitoring, but then you need to tell him where I'm gonna send it. When you send it, you use another plugin called write HTTP. It's called write. It's more like export. You write HTTP to a dashboard. So you specify same as how you set up the collector there. Where is your Splunk? I'm not doing HTTPS, so I'm using a 8888 here, service collector. But with collect D, you have to send as a raw data. So your endpoint extend to raw. And then you have a parameter as channel. This should be include your token both as parameter as a channel and as your header for authorization. It's a weird setup, I know. I tried to delete this part, but it doesn't work. This part doesn't automatically come here, so you have to specify these two at the same time. And format is JSON, because if you remember in the previous one, we mentioned that we're going to accept the JSON format here. And I want to send the matrix, and I want store rate to be true. This part, I'm a bit confused what does it do actually, to be honest. But if I turn to false, apparently my data to Splunk is not showing anymore. So this store rate apparently has to be true for the Splunk to understand what I'm sending here. So here, until now, we're talking about the live streaming data, what your system actually looks like. Now I'm gonna have something handcraft. Performance collection. I guess everyone here have this scenario that you upgrade an NSO. So after you upgrade an NSO, you have specific service, you have a feature that doesn't work as you expected. It becomes a bit slower, but you don't know what kind of slow is it. Is it just because of a static number slower, or it's from a straight line, ON, to a O log n, ON square even. In this case, the first thing I was thinking is, how can I make a tool that makes things more regulated and more close to the network engineer mindset? That's I come to the logs. In the NSO BU, we actually use logs for all the integration testing for NSO. Why? Because if you look at how the logs construct here, you spawn a shell, basically with a shell. And examination mark here, this is send to this shell, send command to this shell. And one question mark means testing the receiving in regex. I use 3 question mark here, basically means absolutely match. So I send commit to this shell, which is my NCSCLI. I will show how I spawn it in a while. But then I see if the return value is complete. You can also use a similar way to test any configuration you have on your network devices. Show running config, show interfaces, inspect interface, and then parse, let's say, interface speed. Then you see if the speed is the same with what you configured. So I think this is very close to network engineer mindset. Makes it much easier. You don't have to write a Python code. Again, write different loop for different scenario, but just need to modify a template like this. And when you're running the log script, because here I separate it into phases. The dot means I'm running the step by step. And here is success because everything I mentioned is matched. If it's something doesn't match, it will fail here. So what I did is, logs actually here. I have a wrapper around it, which is the looping part, the looping from 0 to a certain value. Then for every value, I run the log script. And inside the log script, before I start collecting, I start calling this data collector sh, which is start the memory collection, time collection, and so on. You can customize it. Then I run what I want in NSO side. I start committing and so on. Then I call data processing. I stop the collection. And then, for example, if I want to take the average among this time, I want to take the maximum, minimum value. Then I send to Splunk. Why use Python? Because they have API for it. OpenTelemetry API to be specific. Then I send to collector send to Splunk. So this thing goes over and over again, and I have data eventually end up in the Splunk. So exactly what is inside logs. This is a preparation phase. There's actually another preparation phase before this one. I start up NSO. But in this shell, preparation shell, I start with NSO. This make file actually called ncscli minus c minus u admin, basic ncscli. Then I go to config mode. I start creating the service. This is the predictor we're talking about. If we have time to talk about it. But this is actually creating an order by user list now. And I create it as maximum length of this x value. This is the parameter I inputted when I call the log script in the wrapper, actually, in here. Then I check after I put in this command if my NSO config come back to me. If it does, I start calling the collection script, make collect, which is the script I was mentioning before. Then I start trigger commit complete. From here, you start collecting. After commit complete, because this one is a match, this shell will end. Then I stop collecting the data. And in here, in my script, I actually take the average, then send it to Splunk. Exactly how I send to Splunk, OpenTelemetry API. You specify where you want to send it. It's same as what I showed before. IP, v1 traces, but this time I towards the collector. And then I mentioned what I want to send. Here I want to send what's the x value. This x value is the same as what I put it here. That's the x value I'm going to send. My memory consumption, my time consumption, my commit air, which is the actually allocated memory. Because when NSO goes OOM, out of memory, it's always because allocated memory exceeds. I want to see how much memory I actually use and how much I actually allocated. It can be that my physical memory has a lot, but I allocate more than I actually use. That's going to be a bit awkward, usually. And this is the example I was talking about. It's based on the Splunk Enterprise. But I don't have the Enterprise Splunk there. So you have to spawn your own enterprise with a trial period or apply for this developer license. Then you give you the full feature for like half a year. Then you just spawn this example. There's a README there. And if you like AI generate document, there's a deep wiki article for it. Then you just specify where Splunk and it will do a trick. See if that solves your question there. Otherwise, you can find me afterward. You mean the collector? It's open source. It's from OpenTelemetry committee. We don't make it. Yeah, so it's open source. But in here, I have a pre-configured one. You just need to put your IP address there. And the other tokens and stuff, the same as what you in the Splunk has. Then to work. And this is the log-based performance data collector that I was showed in the previous one. So if you have need to collect performance-wise data, feel free to give it a try to see if it make your life a bit easier. Or you don't have that much Python programmer, you want to just have a network engineer mindset here. I will quick talk about the troubleshooting. Okay, then we go to Q&A. I guess a question to our developers too. This is the log actually on collector. It's a bit exit, sorry about that. So collector is an interesting thing, actually. When it works, it actually don't give you any log. you only thing you're gonna see is everything's ready, beginning, running, and processing data. But when it goes wrong, for example, the data I sending here, or I cannot reach my Splunk to do some kind of configuration problem, then you will see the error comes out. For example, in here, it clearly says I failed to get config, cannot restore the configuration. Basically, something like either data sending has a problem or Splunk is not reachable. But if you only see everything until here in your collector, it actually means everything works fine. Then you need to check the next step. To get the logs from collector, you use the Docker logs, because collector usually a Docker container. And if something wrong before on the NSO side, before sending out, you see in the package logging in the Python VM log. In Python VM log, you usually see exception raised. For example, in here, our collector is not found. That's why I say max entry exceeds with URL, because we cannot reach the collector. Otherwise, if collector is fine, NSO is fine, we need to check if Splunk actually received the data. You check if your event count is still 0, or it raised to a specific value here, or when is your latest event. For example, if I send something right now, say 5 days ago, or my connection doesn't work, right? Eventually, if all of those you have checked, it doesn't lead you anywhere, you have 4 endpoints here, follow your trace ID, do a packet capture, disable your SSL, and see whatever NSO send, if it's come to Splunk correctly. Yeah, I think I have time. Let's go to the questions. Duga, can you hear us here? Okay, then I will try to answer as much as I can. Questions?
Observability, it is the package that are coming with the NSO installation?
No, it's an actual one. But in your installer, you have this package folder. Yeah. It is there. But if you want to use the latest one, for example, in 6.1, you go to CC. It also exists as a separate package on the latest version NSO.
Okay.
Okay? But that only gives you time consumption for now. We're expanding it. So if you have any other kind of suggestion, feel free to talk to us.
Thank you very much, Lee.
Thank you.
That was the last session for today for this breakout room. There is one more session happening on the main stage before our social event today. Thank you.